Good evening, students. We are live now. Okay, Rehan and Navishri has joined, even Likhita, Pragna. Is my audio and video clear? Okay, very nice strength. Okay, thanks for the confirmation. Okay, today in this class, we are going to start new topic. The name of the topic is matrices. In this class, in this session, I am going to give you introduction. Along with the introduction, we will do MCQ type of questions and assertion reason. This class might be a little longer, maybe 1 hour, 15 minutes or 10 minutes, not more than that. Okay, so I like the enthusiasm, the way you are joining the class, so active. Okay, Himanshu Sharma, I am back. Great to see you. Jayashri has joined, Harry, Nason, Pragna, Matthew, Anika, Abhinandan, Nikita. Okay, let's start now without wasting any time. So first of all, let's understand the meaning of matrices. Matrices, a plural of matrix, is a rectangular array or table of numbers, symbols or expressions with elements or entities arranged in rows and columns. So this definition we'll understand with the help of example. Example I have shown here. So what does it mean? In very simple words, it's the arrangement of numbers in rectangular form. See here, in rectangular form, the arrangement of numbers. So inside the square brackets, as you can see here, some numbers are written. So this arrangement of numbers, it's known as matrix. So here the numbers, ma'am, for matrices, how much marks question will come? You can expect 4-mark question from this chapter. Along with that, one MCQ also you can expect. So almost 5 marks. And this topic is very easy. So I want you people to do it. Don't ignore this one. So rectangular arrangement of numbers in the form of rows and columns. Here horizontal are rows, and vertical columns. Horizontal rows and vertical columns. So horizontal like this and vertical like this. So you can see in the given example, we have 2 rows and 2 columns, because this is one row, this is another row, and again this is one column, this is another column. So in this example, we have 2 rows and 2 columns. 2 rows and 2 columns. Rows and columns can be different also, but in this example, I have given you 2 rows and 2 columns. So when we multiply rows into columns, like number of rows into number of columns, then we will get order of the matrix. This is equals to order of the matrix. Here, if I have to write the order of this matrix, the number of rows is equals to 2 and number of columns is equals to 2. So here the order of the matrix is equals to 2 by 2. We pronounce it as 2 by 2, where number of rows and number of columns. So this is order of the matrix. If you multiply order like 2 into 2, it's 4. then you will get here total number of elements. Here you will get total number of elements if you multiply rows into columns. Now let's understand types of matrices. So first type is column matrix. Here the matrix in which only one column is there. The matrix in which only one column is there, that is known as matrix. So here you can see I have two rows. So horizontal rows, vertical column. Horizontal rows, vertical column. So two rows I have and one column I have. So whenever we have one column, that matrix is known as column matrix, row matrix. So in brief, I will explain you so that we can start with the questions fast. Then we have row matrix. Row matrix means in which only one row is there. The matrix in which only one row we have. Here you can see horizontal row. So only one row we have. And columns we have two columns. So this is one column. This is the second column. So here I have one row and two columns. Then we have square matrix. Square matrix in which number of rows is equals to number of columns. In square matrix, number of rows is equals to number of columns. So in all the matrices which I have here given, let's write the order also so that you can understand how to write order. Order normally here we'll write rows into columns. So here how many rows we have? Two rows we have and one column. So its order is 2 by 1. Here for this one, I have one row and two columns. So 1 by 2. Here we have two rows and two columns. Let's do next one. The next type of matrix is diagonal matrix. In diagonal matrix, all the diagonal elements are there. Other than diagonal elements, all elements are equals to 0. And diagonal also, when I consider, the diagonal should be from left to right. The diagonal should be from left to right. For example, if I have any matrix like this, so here we can say other than diagonal, we have all the elements 0. Other than diagonals, we have all the elements 0. But this is not a diagonal matrix. This is not a diagonal matrix. Because their diagonal is from right to left. Diagonal is from right to left, which we won't consider. The diagonal should always be left to right in case of diagonal matrix. Then we have scalar matrix. In scalar matrix, all the diagonal elements. So same diagonal from left to right, diagonal elements are equal. Diagonal elements are equal in case of scalar matrix. Then next we have identity matrix. In identity matrix, diagonal elements equals to 1. Equals to 1. So here the matrices which I have given, the order of these matrices is 3 by 3 because number of rows 3, number of columns also 3. 1, 2, 3, 1, 2, 3. Same here also 3 rows and 3 columns, 3 rows, 3 columns. So one additional thing here I will tell you, because for assertion reason type of questions you have to be very clear with the concepts. So if the statement I say all scalar and identity matrix. All scalar and identity matrices are diagonal matrices. See, all scalar and identity matrices are diagonal matrices. Then this statement is true. This statement is true because we can see here the definition of diagonal matrix is that only diagonal element should be there. Other element should be equals to 0. Here also we can say other elements are 0. Here also other than diagonal elements, all elements are 0. So that means scalar matrix and identity matrix, they are diagonal matrix only. The types of diagonal matrix only. But if I say it conversely, all diagonal matrices are scalar matrices or identity matrices, then it won't be true. if I say all diagonal matrices, if I say all diagonal matrices are scalar or identity matrices, then it will be false. So one way it is true, other way it is false. All scalar and identity matrices are diagonal matrices, but all diagonal are not scalar and identity matrices. Let's see next type. The next one is zero or null matrix. When all the elements equals to zero. When all elements of a matrix equals to zero, that means it's a null matrix. So next one, so these were the types of the matrices. Sometimes for MCQ purpose only we should know. Now how to do matrix operations like addition, subtraction and multiplication. So here in this chapter we have to do matrix addition, matrix multiplication, scalar multiplication of matrices, and we have to do matrix multiplication. Matrix multiplication. So multiplication we will do while solving the questions. Addition and subtraction, I'll just tell you. See, addition and subtraction. First thing which you have to see here, whenever you have to add or subtract two matrices, order of both the matrices should be same. Order should be same. Whenever we have to add or subtract two matrices, order of these two matrices should be same. Like I have given here example, we have to add, suppose this is matrix A and this is matrix B, we have to add them. So first of all, we have to check their order. So the order of this matrix is 2 rows are there, 2 columns are there. So 2 by 2. And for this matrix also the order is 2 by 2. So that means we can add them. So corresponding elements we have to add. Like this 1 will get added with this 1. So 1 plus 1, 2. 3 will get added with this 2. 3 plus 2, 5. This 2 will get added with 5. So 2 plus 5, 7. And the 6 will get added with this minus 1. So 6 minus 1 is 5. Here we have done 6 plus 1. 6 plus minus 1. So which is equals to 5. So corresponding elements we have to add or subtract. Suppose I have this matrix 2, 3, 4, 5. If I have to do its subtraction with another matrix, so same way we have to do. So first of all we have to check order. So order here it is same. So this element subtraction with this one, this with this one, the third this element with this, and this with this one. So corresponding elements we have to add or subtract. So order should be same for addition and subtraction of two matrices. Matrix multiplication and scalar multiplication I will teach while doing questions. Now equality of matrices is there when two matrices are equal. Equality of matrices means in which case two matrices, if they are equal, then how we have to equate. So again, first of all, if they are equal, order should be same. If they are equal, order should be same. If matrices are equal, their order should be same. So here we can say the order of this matrix 2 by 2. The order of this matrix is also 2 by 2. So rows into columns. Rows into columns. Number of rows into number of columns. Like how we write the order. So corresponding elements will equate. If two matrices are equal, then first element of first matrix is equals to first element of second matrix, like A is equals to 1. Second element of first matrix should be equals to second element of second matrix. Then C, if we compare here, then C will be equals to 3. This is the first element of second row, and D it is equals to 8. This is the second element of second row. So corresponding elements, they will be equal if two matrices are equal. So these are the concepts which you should know. If any other concept is there, those concepts I will explain you while solving the question. So let's start questions now. So before I start questions, I just want to ask if anyone has any doubt, you please let me know. Anyone, any doubt? If anyone has any doubt, you can just tell me your doubts. If no doubts, then let's start with the question. So before I start with the question, I want you people to keep your notebooks or pen along with you so that you write it down, make notes along with me and solve the questions along with me for better understanding. Let's start with the first question. Okay, so in first question it's given. So this question is, if A is equals to, so matrix A is given to us and matrix B is given to us. 1, 0, negative 2 and 3. So two matrices are given. So they are asking here which of the operation is possible. Operation means like addition, subtraction, multiplication. So here this we have to check. So C option A, B. Yes. See, for matrix addition and subtraction, if I have to do addition or subtraction, order should be same. Order should be same of both the matrices. But here if you see order of A matrix, what's the order of matrix A? So you can post your answers. What is the order of matrix A and matrix B? So here we have one row and two columns, horizontal rows and vertical columns. So it's not 2 by 1, it's 1 by 2. One row, horizontal row, vertical columns. So one row, two columns. So rows RC, you remember RC. So rows into columns we do whenever we write order. Then the order of the second one is 2 by 2. So order is not same, so that means first option is not correct, second is also not correct because addition and subtraction is not possible. So here multiplication, I'll tell you, like I told you, we have to, I'll tell you for multiplication now itself. So whenever we have to do matrix multiplication, with the help of order we can check whether multiplication is possible or not. For matrix multiplication, you have to remember number of columns. Number of columns of first matrix. Here it's A. Number of columns of first matrix should be equals to, so here it's better you can write first matrix. Number of columns of first one, it's equals to number of rows of second. Number of rows of second. So for matrix multiplication, this concept we have to use number of columns of first matrix, it should be equals to number of rows of second matrix. If it is equal, then matrix multiplication is possible. Now if we see, so here two options are there. A into B means, AB means A into B. So let us write both the orders. So here 1 into 2 is the order of A and 2 into 2 is the order of B. So here it's the columns of first one and this is rows of second one. So here we can see both of these are equal. Both of these are equal, which means option C is correct. AB is possible. So option C is correct here. We can multiply. Say you can check for BA also. BA means when we have to multiply B into A. B into A. Is it possible? We can write B's order. B's order is 2 by 2 and A's order is 1 by 2. So if we compare columns and rows of first and second respectively, so they are not equal. So that means B into A matrix multiplication is not possible. B into A matrix multiplication is not possible. So the possible option here is option C. You can write both the orders and middle one should be same. Middle one should be same like this one. So 2 and 2 are equal. That means matrix multiplication is possible. So anyone any doubt? So have you understood when matrix multiplication is possible? Okay, let's do the next question. In next question, we have to do multiplication. and we have to find the value of x and y respectively. So two matrices are given to us. I'll just rewrite. So 2 0 0 4 with xy. See, when there is no plus minus in between, altogether they have written. They have written both of these. Here no sign, no nothing is there. So that means these two are getting multiplied. So you have to understand that these two are getting multiplied because here nothing is written in between them. So how to do matrix multiplication? So we have to do multiplication and find the value of x and y. So first of all, like I have told you, we write order like this. R, C, rows, columns. So same thing we will do. First matrix rows we will use. First of all, we have to check also. Here they have given answer also. That means matrix multiplication is possible. So first one's rows we will use. First matrix rows we will use. Second matrix columns we will use. If you want, you can mark like this. I have marked differently. So like this you can mark for your understanding so that no mistake can happen. So you have to mark rows and columns like this. In matrix multiplication, see one row and one column. One row and one column will give you one element. Just remember always. Now how to do? I'll just write. So 2 into x. 2 into x is 2x plus we have to write plus 0 into y. 0 into y. This is done. Now 0 into x, 0x plus 4 into y. This is equals to what? 2 comma minus 8. So I have gotten here 2x plus 0y means 0 and 0x is 0 plus 4y. This is equals to 2 minus 8. Now we have got two matrices and equals to sign is there. That means we have to equate these matrices, and if we see their order is same. So 2 rows and 1 column, 2 rows and 1 column. So we can equate the elements. So 2x from this matrix is equals to 2. So this element we have to equate with this element. So from here we can find the value of x. So 2 by 2 which is equals to 1. Same way this element 4y is equals to minus 8. So 4y is equals to minus 8. Y is equals to minus 8 by 4 which is equals to minus 2. So 1 minus 2 is the answer. Very good. Many of you have given the answer before me. Abhinandan, Matthew, Shreyasi, Yatin, Raya and Navishri. Okay, good. Let's do next question. In next question, one matrix A, B, C, D. In general, it's given to us. It is getting multiplied with some another matrix and its answer is PQ. See, matrix you always have to remember, we always represent matrix with capital alphabet. We always represent with capital alphabet, capital letter. Like here, if I have to write also some matrix, I will write capital A is equals to A, B, C, D. So matrix we always represent, like here capital X is given. So that means this X is some matrix. If small letter is there, that means only element is written. Now they are telling what is the order of matrix X. So now we know the order of this matrix. The order of this matrix is 2 by 2. And the order of this matrix is 2 rows, 1 column. So 2 by 1. So I'll tell you one thing. Whenever we are multiplying any two matrices, suppose I am multiplying two matrices, their order is 2 by 2 and I am multiplying it with some matrix whose order is 2 by 1. For matrix multiplication, these two should be equal. For matrix multiplication, the middle one should be equal. Suppose this is some matrix A and this is some matrix B. I have to check whether I can multiply these two or not. So for that, this is the order of matrix A and this is the order of matrix B. So I got number of columns of the A is equals to number of rows of matrix B. So that means it's possible. Now if you see the outer numbers, outer numbers is 2 and 1. If you join them, if you write it as 2 by 1, this will give us the order of resultant matrix. Order of resultant matrix. Like once these two matrices are multiplied, once these two matrices A and B we multiply, we will get some matrix C. We'll get some matrix C whose order will be this. The outer ones you have to see. So same concept here we will use. Now some matrix X, I will write its order I will write as small a. I can write as X into Y. Small x into Y. First of all, this matrices, they are getting multiplied. That means the columns of first one should be equals to rows of second matrix. The columns of first one should be equals to row. So this is rows, this is column. This is rows, this is columns. So this should be equal. This should be equal. So that means 2 is equals to X. So X order is X into Y we wrote. So I got the value of small x as 2 because this both should be equal. Now if I see the outer numbers, if I see the outer ones are this 2 and Y. If we see the outer ones are 2 and Y. So 2 into Y will be the order of the resultant matrix. But my resultant matrix order is 2 by 1. So that means this should be equals to this. So if we compare these two, we'll get Y is equals to 1. We'll get Y is equals to 1. So from here we are getting the order of matrix X is equals to 2 by 1. So option C. It's option C. So many of you have given me the answer before itself. Harry, Jayashri, Abhinandan, Shreyasi, Nikhil and good. So if anyone has any doubt, you can just tell me. Now next question. So in next question, we have to find the value of X. So it's given to us this matrix 2, 0, X, 1. This is one matrix. It's getting added with another matrix 2, 1, 4, 0. And when we are adding the resultant matrix, we are getting this one. Now if I write question number 3. Okay, 1 second. I'll just once again explain. Those who haven't understood, suppose I am multiplying matrix A with matrix B. After multiplying, I am getting matrix C as the answer. I am multiplying matrix A with matrix B. Suppose the order of matrix A is 2 by 1 and the order of matrix B is 1 by 1. I am just giving you one example. If you multiply these two, then these two should be same. Then only matrix multiplication is possible. That means columns of the first matrix should be equals to rows of the second matrix. And the order of the resultant you will get from this number, the outer numbers. That means rows of the first one into columns of the second one. Rows of the first one and columns of the second one will give you the order of the resultant matrix. So here the order of C is what? The order of C is 2 by 1. Is this thing clear what I am trying to say here? Someone has asked the doubt question number 3. So have you understood the concept? If you have to multiply two matrices, the columns of first matrix should be equals to rows of the second matrix, and also the order of the resultant matrix is equals to rows of matrix first into columns of matrix second. So this concept we have used here. Here matrix A is getting multiplied. Here matrix A is getting multiplied with matrix X. and we are getting some answer. Suppose this is matrix B. So order of A is 2 by 2 and order of X we don't know. We can write it as small x into Y. Order of B is given to us. This is 2 by 1. Now these two should be same. The inner one should be same. So that means X should be equals to 2. X should be, so order of X I have assumed as X by Y. So X should be equals to 2 because columns of first one should be equals to rows of second one. So that means 2 should be equals to X. If you see the outer numbers here, what it is 2 and Y. So 2 into Y, when I am writing, it will give me the order of the resultant matrix. So which is matrix B. So that means if I compare 2 into Y with 2 into 1, so Y's value I'll get equals to 1. From here I'll get the order of matrix X as 2 by 1. So is it clear? I hope you are able to understand. Someone asked me doubt. Is it clear now? Okay, most welcome. Let's do next question. Many of you have done it. I hope you are enjoying the class, but the class strength is decreasing. I don't know why. You can do the questions along with me. So now here two matrices we have to add, but before adding you have to see here one 3 is written outside. See, when 3 is written outside, right, like bracket multiplication, this 3 will get multiplied with each and every element of the matrix, and this type of multiplication is known as scalar multiplication. This type of multiplication is known as scalar multiplication of matrices. So this is 2x01. This matrix I have to add in this one. So after doing scalar multiplication, 2 into 3 is 6, 3 into 1 3, 12 0. So this is equals to 8 12 8 1. So two matrices I can see their order is same. Their order is same. So that's why they are getting added. Now elements we have to add. So 2 will get added with. So two matrices are there. First of all, these two matrices we have to convert into single matrix so that we can compare. So 2 plus 6, 8 plus x plus 3. X plus, here plus will not write. So 2 plus 6 is 8. Second element x plus 3. Then here 0 plus 12 is 12. 1 plus 0 is 1 is equals to 8, 12, 8, 1. So this element I added with this one. This x I added with this 3. This 0 I added with 12. And 1 I added with 0. Now we can compare. I need this one only. So this element I have to equate with this one. So first row, the second element on both the sides I have to equate. So x plus 3, when I am equating with 8, I will get x value as 8 minus 3, which is equals to 5. So we got the value of x as y, 5. So you have given me the answers. Shreyasi has given Divyashri, Abhinandan, Matthew, option D. So 5 is the correct answer. Now let's do next question. In next question, we have few statements. We have to see which one is possible. So question number 5. The product AB of two matrices. I want you people to give the answer because in a very good way I have taken the doubt also. This concept I have explained. In which case A into B is possible. In which case A into B is possible. So let's see who will give the answer first. So A and B have same number of rows. Is it possible? So in which case A into B is possible? Okay, no answers till now. So first option they are telling there both should have same number of rows. Second option, number of columns of A should be equals to number of rows of B. Then number of rows of A should be equals to number of columns of B. And then A and B have same number of columns. Yes. So Khushbu, so yes. Monish, many of you have given option B. So that's what I have explained. Number of columns of A matrix should be equals to number of rows of matrix B. Good. So that means you have understood. Very good. Let's do next question now. A matrix is given to us. Then I is identity matrix. Capital I when we write, this is identity matrix. Identity matrix of order 2 we write like this. It's given also. So they are telling what is the answer of AI. AI means A into I. See, I is identity. Like if you identity is like 1. If you multiply anything with identity, like if you multiply 2 with it's 1, so you'll get 1 only. If you multiply anything with 1, your answer is always 1 in case of real numbers. So the identity of matrices is written in this way. Same way, if you multiply any matrix with its identity, the answer will be same. So you don't have to do multiplication here. Just remember a concept. Any matrix when we multiply with the identity matrix, this is identity matrix, then the answer is the matrix itself. So here option C is the correct answer. No need of solving. Option C. So which of the following is a, next question I am doing, which of the following is a vertical matrix? So vertical and horizontal, I didn't explain you. See, if the matrix from figure itself, you can just figure out like from the way the matrix is looking. So vertical means like this. Vertical means like this. This is vertical, the straight line, and this line is horizontal. So if matrix looks like this, that means it's a horizontal matrix. If matrix looks like this, so that means it's vertical matrix. And these two we already know. This one is square matrix because number of rows and columns are equal. This one is also square matrix as well as null matrix. So option C, vertical, this. So here number of rows are more than number of columns. So 1, 2, 3 rows are there. So this type of matrix is vertical matrix, and the A matrix, matrix A is horizontal matrix. Let's do next question now. Question number 8. Let's do next question. Question number 8. Value of x we have to find. Equality concept we have to use because both the sides we have one matrix. Here I have one matrix. Left side I have one matrix and right side also I have one matrix. Both the sides 1 1 matrix and their order is same. So order of this matrix is 2 by 2. For this also 2 by 2. 2 rows, 2 column. 2 rows, 2 columns. Horizontal rows, vertical columns. So in this case, corresponding elements we can equate. So this element, because we have to find the value of x. So 3x minus 6 is there in this element. This is the second element of second row or second element of second column also you can use. So this is equals to 0. This element should be equated with this element only whenever we are equating two matrices. So let's solve the equation. So 6 when we shift to other side, it's equals to positive 6 because here it's negative 6. 3 when we shift to other side, it will get divided. So x value will get x is equals to 2. So option A. Option A. Let's do next question. It was very simple. So many of you have given the answer option A, x is equals to 2. Let's do question number 9. Equation number 9. So two matrices are given to us. Then AB is equals to, I think I forgot to share all the options. So C and D options only I could by mistake, I think. So no problem. Let's multiply AB. We have to find AB. That means A into B we have to find. So matrix multiplication we have to do. See here, this 3, 5, 0, 1. This is first matrix. Whenever you are doing matrix multiplication, so first matrix always you have, if here it's written B into A, then you have to write B into A only if BA is written. So AB is written means A into B only you have to do. You can't do it A into B. Why I am telling? Because in case of matrices, A into B is not equals to B into A. Matrix multiplication is not commutative. Is not commutative. Like normal multiplication is commutative. I know 2 into 2 is 4, 2 into 3 is 6 and 3 into 2 is also 6. But in case of matrices, this is not true. Matrix multiplication is not commutative. A into B is not equals to B into A. So this you have to understand. Now let's do multiplication and find out the answer. This is -4, 1, 2, 0. This is the proper question of matrix multiplication. I'll explain you also one question we have already done. So order is, both the matrices order is 2 by 2. 2 by 2. So that means these two are same, the inner numbers. That means columns of the first one is equals to rows of the second one. So this means matrix multiplication is possible. And if you see the outer numbers, it will get 2 by 2. That means our resultant matrix order is 2 by 2. So let's do now. First of all, from first matrix we will see matrix multiplication is very important. You will get surely a question in which matrix multiplication will be required in your board exam also. So learn it properly. First of all, for your reference, with pencil you can mark rows of first matrix and columns of second matrix. Rows of first matrix, like I told you RC, you can just remember rows of first, while writing also and while doing matrix multiplication also, rows of first matrix you can mark for yourself and columns of second matrix. Now how we have to do? See, one row and one column, one full row, that means 3 0 and 4 1. One full row and one full column will only give us one element. Always remember, one full row and full column will give us always one element. How to do? 3 into 4 will multiply 3 into -4 plus first element into first element, then plus second into second. 0 into 1 we have to do. So 3 with 4 we multiplied, then plus 0 with 1 we multiplied. Then again this one, first I used this with this, now this one I'll use with second column. So 3 into 2, first with first, plus 0 into 0. Now this one I'll use with this one, and then this one I'll use with this one also. So first element I have to multiply with first element, then plus second element I have to multiply with second element. Then first element 5 into 2 plus 1 into 0. I hope this is clear. So 3 into -4 is -12, 3 into 4 12, 0 into 1 is 0, 3 into 2 is 6, 6 plus 0 into 0 is 0. So -20, 5 into -4 is -20, 1 into 1 is 1, 5 into 2 is 10, plus 1 into 0 is 0. So further I can simplify. So -12 plus 0 is -12, 6 plus 0 is 6, plus minus minus. So here we'll get -19 and here we'll get 10. Yes, so Nikita has given the answer -12 0, -19 10. So that's the correct answer. So I'm not sure which option it will be because I just forgot to here write all the 4 options. So this is the answer. Option B is not the correct answer for this one because only 2 options are there. So I missed out remaining 2 options. Have you all understood matrix multiplication? We will do many more questions, but still if anyone has any doubt you can just tell me. And the best thing is that always just with pencil mark the rows and columns like the one I've done. Okay, good. Let's do next question. Question number 10. So this is the last MCQs. After this assertion and reason we will start. So A is given to us, matrix A is given to us. This is 3, 5, 0, 1. This is matrix A. What we have to do? We have to find matrix A square. So what is the meaning of A square? A square is A into A. A square is A into A. So A into A we have to find. So what we will do? A with itself we have to multiply. So like this. So A matrix is 3, 5, 0, 1. With itself I have to multiply. So again same thing I'll write. So here rows of first one we have to mark, rows of the first one we have to mark, and the columns of the second one we have to mark. So here if you see their order, so A's order is 2 by 2. Again 2 by 2, so middle ones are same, so that means multiplication is possible. Outer ones will give us the order of the resultant matrix. So 2 by 2 is only the order of the resultant matrix. Suppose B is the resultant matrix, so its answer is, its order is 2 by 2. So let's multiply. So one row and one column will give us one element only. So 3 into 3, 9. So I'll not write directly. So 3 into 3 plus 0 into 5. First element with first I have to multiply, then plus, then second element with second element. Then here this one with both columns I have to do, and this one with both columns we have to do. So 3 with 0, 3 into 0 plus 3 into 0 plus 0 into 1. Now second one I am doing, so 5 into 3 plus 1 into 5, then 5 into 0 plus 1 into 1. First element with first I am multiplying, second with second. So for second column also, first with first element, second with second. So we'll see what we'll get. 9 plus 0, 0 plus 0, 15 plus 5, 0 plus 1. So what we'll get? 9, 0, 21. 9, 0, 21. Yes. So which is option A? Yes, so it is option A. So let's do next question. If till here anyone has any doubt, you can just tell me. If any doubt is there, let me know. Okay, I guess no doubts. Let's start assertion reason. So options are there. As per the options, we have to mark the answer for next few questions. These options we have to consider. Okay, so first option is A is true, R is false. Second option is A is false, R is true. Both A and R are true, both A and R are false. So always the options won't be same. Like whatever options here they are given, those options only you have to consider while answering this. Now first option, first statement A, assertion. It's given if A is equals to, A is some matrix. See, with always capital letters we are representing matrices. So here A is given to us and matrix B is also given to us. So A is 3, 5, 0, 1 and matrix B is also given to us. So B is equals to minus 4, 1, 2, 0. So they are telling A plus B. A plus B is equals to some matrix is given to us. So let's find A plus B. Let's find A plus B when we are adding. So 3, 5, 0, 1. A, first of all I have to write A matrix, then plus, then we can write matrix B, 4, 2, 1, 0, then corresponding element. So this element 3 should get added with minus 4, 0 should get added with 2, 5 with 1 and 1 with 0. So if I add, so I'll get -1, 2, 6, 1. Yes, so this is what they also have given. This is what the same thing they have given. A plus B is equals to this. So that means A is true. A is true. So commutative property. A plus B is equals to A plus B is equals to B plus A. So whenever we do matrix addition is commutative. A plus B is equals to B plus A. Multiplication is not commutative, but addition is commutative. Commutative means when we interchange A and B. So addition is commutative. Matrix addition, commutative. But always remember, matrix multiplication is not commutative. So that means R is also true. So option C, both A and R are true. Yes, both are true. Very nice. Many of you have given the answer. Let's do next one now. Same option we will be considering. So it's mentioned, it's given to us A is equals to, so one matrix is given. Order of the matrix is 1 row and 2 columns. So 1 by 2, and the order of, I'll write here, order of first matrix is 1 by 2 and the second matrix 2 minus 4 0 0. So this is 2 by 2. It is equals to 0. It's equals to 0. 0 we can write as null matrix also. Let us find what will be the order of resultant matrix. If these two are equal, so matrix multiplication is possible. The outer ones is giving us, so 1 by 2. 1 by 2 is the order of resultant matrix. 1 by 2, so 1 row, 2 columns. 1 row, 2 columns means our resultant matrix should have 1 row and 2 columns. So null matrix I can write like this also, 0 0. Now I have to find, so they are telling if this thing is there, x value is 2. Let us find the x value and check whether it is true or not. So matrix multiplication we have to do. Multiplication how to do? Rows of first one will use and columns of second one. So I will get, so 2x plus minus 8 and 2 into 0. No, this is, this with this also I have to do, and with this also. So because we are getting a resultant matrix of 1 by 2 order. So x into 0 plus 2 into 0. This is equals to 0 0. So I'll get here 2x plus minus minus 8. So this is 0. So this will also become 0. 0 plus 0 is 0. This is equals to 0 0. So this element we can equate, because equality of matrices we have to do. So 2x minus 8, it's equals to 0. 2x minus 8 equals to 0. When this is linear equation, when we simplify this, I'll get 2x is equals to 8. Minus 8, when we shift to other side, it will become plus 8. So x is equals to 8 by 2. When I solve, I am getting the value of x as 4. So x value is equals to 4. So without solving, we can't tell. I can see many of you told A is true. You have given me in the comment section that A is true. See, assertion and reason type of questions are very, very logical. You have to solve it and then only you can decide whether it is true or false. So A is false. X answer we are not getting 2, but we are getting 4. So reason also same thing they have mentioned, but they have mentioned x is equals to 4. So that is true. We have checked also, x answer 4 only we are getting. So that means here A is false, R is true. So which option is this one? A is true and R is false. I hope you remember the options. A is false and R is true is B option. Option B. No one remembers. A is true, R is false. Option A is false, R is true is option B. Let's do next question. Assertion is given to us as symmetric, and reason if A is a symmetric, A is equals to A dash. So here one concept is there that I'll teach you, then we can answer this question. So there is a concept of transpose of a matrix. There is a concept of transpose of a matrix. So what is transpose? Where rows and columns they interchange. When rows and columns interchange. So that means it's the transpose. Suppose A matrix I have 1, 2, 3, 4. So A transpose I can also write as AT or A dash also I can write. Both ways we can write AT or A dash. So how I will write A transpose? Transpose of A, because I told you rows and columns will interchange. Now this is the row. This will become column. This is the row. This will become column. So this is the meaning of transpose. So now another thing is symmetric matrix. When A matrix A is equals to its transpose. When matrix A is equals to its transpose, that matrix is symmetric matrix. That matrix is symmetric matrix. When A matrix is equals to its transpose. Have you understood what is the meaning of transpose of a matrix? When we interchange rows and columns, that means transpose of a matrix. So let's see the given thing now. So I've already told you, if A is a symmetric matrix, then A is equal to its transpose. That means reason is true. Assertion we have to check. If A matrix is equal to its transpose, then the given matrix is a symmetric matrix. Now they are telling if this is symmetric matrix, then X is equals to 6. So I'll just write A is equals to here 2, X minus 3, X minus 2, 3 minus 2 minus 1, 4 minus 1 minus 5. Let's write its transpose also. If I write transpose, so rows you change it to column. This full will become column 2 x minus 3 x minus 2. This full will become column 3 minus 2 minus 1. This full will become column 4 minus 1 minus 5. So now they are telling they are symmetric. That means A is equals to its transpose. So if A is equals to its transpose, the corresponding element should be same. That means this element should be equals to this, and this should be equals to this. So let's check what we are getting X value. So X minus 3 should be equals to 3. So here I am getting X value as 6, and also X minus 2 should be equals to 4. From here also I am getting X value as 6. So this is the correct answer they have given. They have given us X is equals to 6. That means this is also true. This is also true. So here also option C, both are true. C option, both are true. Let's do next question now. Question number 4. See, 5 questions are there, which so one more question and then I'll end the class. So don't be impatient. Only one more question after this. Now, if the order of the matrix A, so A's order is 3 by 4 and B's order is 3 by 4, C's order is 5 by 4. So this is given to us. Then they are telling order of A transpose into B into transpose of C is equals to 4 by 5. So first of all, let's write the order of their transpose. So order of transpose equals to opposite we will do. A's transpose, it will become 4 by 3. Then B's transpose order will become 4 by 3. And transpose of C's order, it will also become 4 by 5. So opposites. So 3 by 4 will, because we are interchanging rows and column. Now this one we have to check. This one. So for this, first of all, let's check the order of A transpose into B. If we multiply, see, A transpose order is 4 by 3, B's order is 3 by 4. So these are same. If we multiply, their resultant order will be 4 by 4. So the order of A transpose, into B, this one's order is what? 4 by 4. Now this we are multiplying with C transpose. So what is the order of C transpose? 4 by 5. So this is same, and the resultant order will be 4 by 5. So this is what they have given us also. This is what they have given. So that means this is true. That means this is true. Like resultant matrix, while doing multiplication, I have told you the outer numbers you see, that will give us the order of the resultant. First of all, I found the order of A transpose into B. Its order is 4 by 4, and C transpose order is 4 by 5 here itself. So if we have to do its multiplication, so order of resultant will be the outer ones, 4 by 5. So A is true. Now let's check the reason statement. So what is mentioned in reason? The multiply an m into n matrix by n into p. So if you are multiplying m into n matrix with some matrix whose order is n by b, then n must be same. Yes, so n must be same, and the result is m by p. Also, A is a matrix of order m by n. Then the order of the transpose, also A be a matrix of order m by n. Then the order of transpose of a matrix is n by m. So is it true? Is it true? Yes, A is true. R is also true. R is also true. See, if any matrix order is this, the order of its transpose will be opposite. So its opposite will be n by m. So both A and R are true. So option C is the correct answer. Yes, both are true. Let's do the last question, reason and assertion. So question number 5, statement A, matrix A is given to us 2, 6, minus 2, 4, 0, minus 2. Can anyone tell me what's the order of this matrix? What's the order of matrix A here? What is the order of matrix A as well as matrix B? What is the order? Fast. So 2 by 3, Shreyasi has mentioned 2 by 3. When Jayashree has given 2 by 3. Okay, very good. What about B matrix? What about matrix B? Yes, matrix B is 3 by 1. Very good. 3 by 1. So 2 rows, 3 columns, 3 rows, 3 rows, 1 column. So very nice. You people are able to figure out the orders. So now they are telling AB transpose is this. So first of all, we have to find AB. That means A we have to multiply. We have to multiply matrix A. This is 2, 6, minus 2, 4, 0, minus 2. And this one is 2, 6, 10. So matrix multiplication we have to do, because AB we have to see its order is 2 by 3 and its order is 3 by 1. So these inner ones are same, that means matrix multiplication is possible. Outer one will give us the idea of the resultant's order. So order of its resultant is 2 by 1. So 2 rows and 1 column. So same way we will do, we'll mark rows of the first matrix and column of the second matrix. So 2 rows we will get and 1 column we will get. So 2 with 2, So this we have to multiply with this and this we have to multiply with this. So 2 into 2 plus minus 2 into 6 plus 0 into 10. Then 6 into 2 plus 4 into 6, 4 into 6 plus minus 2 into 10. So this we have to do. Answer you can post also. If you're doing it before me, you can tell me the answer. What is the answer of matrix AB we are getting? So here I'll just add 2 into 2 is 4. 4 minus 12. 4 minus 12. Minus 2 into 6 is minus 12 plus 0. Then 6 into 2 is 12 plus 4 into 6 is 24 minus 20. So this is what we are getting. So 4 minus 12 is minus 8. Minus 8 plus 0 is 0. 12 plus 24. Or here we will do 24 minus 20 is 4. 4 plus 12 is 16. So this is matrix AB. A is true and R is false. Okay, Monish has given the answer. Yes, so AB we have found this. So but we have to find AB's transpose. So we'll just, these rows will change to column. So this will be minus 8, 16. This is what given to us. So that means this is true. So if reason is true, that means no, assertion is true and reason is false, because this is the value of AB transpose we got. This is not the value of AB. So this is false. A is true, R is false. So which option? It's option A. A option. A is true, R is false. So anyone, any doubt? A is true, R is false. So here we have completed all the assertion reason based question also. So I hope you have understood. If anyone has any doubt, please let me know if any doubt is there. Okay, so subjective type questions we will do in the next class of matrices, and we'll finish this chapter in 2 classes. Okay, good. Thank you for attending the class. I hope I will see you in my next class.